Vitamin B6 refers to the group of three compounds, namely pyridoxine or adenine, pyridoxal and pyridoxamine, which are interconvertible in the form of their phosphates. But since pyridoxine is the first member of this group, it is known as vitamin B6. It is not affected by heat, acid or alkali, but is destroyed by oxidizing agents. The deficiency of this vitamin in rats causes a specific dermatitis, inhibition of growth, and reduction in accessory reproductive organs, leading to defective sexual behavior. In man, its deficiency causes pellagra or anemia. Constitution. Molecular formula C8H11NO3. Double bond equivalent 4. So there is a possibility of benzene or pyridine skeleton present in the structure. It behaves as a weak base. Usual test showed the absence of methoxyl methylamine and primary amino groups. Likeliness of pyridine ring. Zarevatnov method showed the presence of 3 active hydrogen atoms. Since no NH2 or NHCH3 is present, possibility of presence of hydroxyl group. Red deep color with ferric chloride. This means one OH group present as a phenolic. Monomethyl ether formation takes place on reaction with diazomethane. Also, UV spectrum of pyridoxine is quite similar to beta hydroxypyridine, confirming presence of pyridine and phenolic group. Monomethyl ether of pyridoxine formed on reaction with diazomethane does not give color with FeCl3. It forms diacetate with acetic anhydride. It reacts with HBr to form a dibromide. It indicates the presence of OH group. Monomethyl ether of pyridoxine is not attacked by red tetraacetate. Absence of 2 adjacent hydroxyl groups in the side chain is confirmed. Kuhn-Roth method of oxidation, that is oxidation by chromic anhydride. This points out the sequence of 1CCH3 group. Monomethyl ether of pyridoxine, when oxidized very carefully, with the alkaline KMnO4 gives a methoxypyridine tricarboxylic acid. This tricarboxylic acid gives a blood red color with ferrous sulfate, a characteristic reaction of pyridine to carboxylic acid. Thus, one of the three acidic groups in the tricarboxylic acid must be a 2 position. Usual oxidation of monomethyl ether of pyridoxine with alkaline KMnO4 gives a molecule of CO2 and anhydride of COOH. Anhydride formation indicates that in the present tricarboxylic acid, 2 of dicarboxylic acid are ortho to each other. Ortho dicarboxylic acid obtained by hydrolysis of anhydride, the one in which loss of Ca2 has taken place, does not give a red color with ferrous sulfate. It does not have a carboxyl group in the second position. This means on decarboxylation, tricarboxylic acid eliminates 2 COOH group to form anhydride. Tricarboxylic acid may have either of following structures. We know that pyridoxine methyl ether has one OCH3 and 2 alcoholic group. Thus, the 2 COH groups in the tricarboxylic acid could arise from 2 alcoholic groups. The third must have arrived from a methyl group. The following structures are possible for pyridoxine and its corresponding methyl ether. 2 possible structures of pyridoxine methyl ether. A decision between 2 structures was made on the basis of following points. Vitamin B6 monomethyl ether on oxidation with barium permanganates gives a dicarboxylic acid first. The dicarboxylic acid forms anhydride with acetic anhydride and gives a fluorescent dye with resorcinol, indicating that the 2 COH groups are ortho to each other. Moreover, the dicarboxylic acid first does not give color with ferrous sulfate solution, showing that neither of 2 COH group is in alpha position to the nitrogen. Hence, the structure of dicarboxylic first may be either A or B. The position of the 2 COH groups in first corresponds to 2 alcoholic groups in pyridoxine. However, Cohen compared these 2 dicarboxylic acid with synthetic compounds and found that the dicarboxylic acid obtained from pyridoxine is A, as it resembles with the synthetic dicarboxylic acid from 4-methoxy-3-methyl isoquinoline. Hence the correct structure for 1 is A, and thus pyridoxine will be second, which explains all the reactions. Synthesis. Cyanoacetamide reacts with ethoxyacetyl acetone. In the presence of piperidine as a base and methanol as solvent. A 6-membered ring was formed. It is like an amide, cyclic amide, that is lactam. It undergoes tautomerization, leading to the formation of COH and double bond N. This, when treated with nitrous acid, nitric acid and acetic anhydride, gives the nitro product. This is then reacted with phosphorus pentachloride. Also, in the second step, hydrogenation takes place. Leading to in this case, OH gets replaced by Cl. Also, NO2 gets reduced to NH2. In presence of palladium carbon catalyst, hydrogenation makes cyano getting converted to CH2 NH2. This is then treated with nitrous acid, HNO2, so NH2 gets converted into alcohol. In presence of HBr, brominated product is obtained. It is then treated with HBr, and so ether gets hydrolyzed in presence of HBr to CH2Br, and CH2OH is hydrolyzed such that it becomes CH2Br. This, when treated with water and AgCl, makes the formation of pyridoxine.